Let us look at this question of definite integrals. Question is function f from this interval, close interval minus pi by 2 to pi by 2 to set r be a continuous function such that f of 0 is 1 and value of this definite integral is 0. Here we have integration of f of t from lower limit 0 to upper limit pi by 3. If value of this definite integral is 0, then which of the following statements are true? This is multiple correct answer type questions. So we have to check all the options. Okay. First option, option A is equation fx minus 3 cos 3x is equal to 0 has at least one solution in open interval 0 to pi by 3. Now, what do you find in this statement? What are the keywords? This equation has at least one solution in this interval. Okay, that means here we can think of using Rowley's theorem. Okay, in that case, this must be derivative of some function. Okay, which becomes 0 in the interval 0 to pi by 3. Okay, so we create a function whose derivative is this function gx is that function. So gx will be here we have fx. So we create here term with integral. We have we must have integration of f of t from lower limit 0 to upper limit x. Okay, derivative of this will be f of x. Okay, so we are creating this term. And this is derivative of sine 3x. Okay, we add some constant. Okay, now for Rowley's theorem we check the value of function gx at x is equal to 0 and x is equal to pi by 3. We find g of 0 is equal to, put here x is equal to 0, we find 0 minus 0, sine 0 is 0, this plus c, this is equal to c, and g of pi by 3 is equal to, we replace x with pi by 3 and value of this definite integral is 0, this is given. So we have 0 minus, we will have here sine pi is 0, so we have this plus constant c is equal to c. So we are getting g of 0 is equal to g of pi by 3. Okay. So here Rowley's theorem is applicable, and from its argument we can say there exists at least one alpha belongs to 0 to pi by 3 for which g dash alpha will be equal to 0. Okay, and derivative of this is fx minus 3 cos 3x is equal to 0. So this equation has at least one root in the interval 0 to pi by 3. Okay, so here we are using Rowley's theorem. In second case, in second option equation, this equation has at least one solution in this interval. In this case also we will be using Rowley's theorem. Now here we rewrite this equation by taking minus 6 upon pi on LHS. We get equation fx minus 3 sine 3x plus 6 over pi is equal to 0. Now this equation has at least one solution in this interval. So what do? We create one function whose derivative will be this. Okay, that function hx will be definite integral, this definite integral. Okay, its derivative will be f of x. Okay, this is derivative of minus 3 sine 3x is derivative of plus cos 3x, and this is derivative of 6x over pi. Add some constant c here. Okay, now h of 0, we check the value of hx at 0 and pi by 3. H of 0 will be 0 plus 1, cos 0 is 1, plus 0 plus c, this is equal to c plus 1. Okay, and h of pi by 3, replace x with pi by 3, we find 0 because value of this definite integral is 0. So we have 0 plus, here we will have cos pi is minus 1. Okay, plus 6 over pi into pi by 3 plus 2. Okay, plus constant c, this is also c plus 1. Okay, so this function satisfies conditions of Rowley's theorem. So from the argument of Rowley's theorem, there exists at least one x belongs to this interval for which derivative of this will be 0 and derivative of this is this function. Okay, so this option is also true. Both the options A and B are true. We used here Rowley's theorem. Okay. Okay, now in these two options we have limit involving definite integrals. Definitely we will be using here Leibniz rule. Okay, this one, limit extends to 0 of x into this definite integral over 1 minus e power x square is equal to minus 1. But x is equal to 0, we find 0 over 0, e power 0 is 1, so we have 0 over 0 indeterminate form. We can use L'Hopital rule. Okay, for that we differentiate numerator and denominator separately. Okay, so this limit changes to, limit extends to 0 of 1 into this definite integral, okay, plus x multiplied by fx over derivative of this, it is minus 2x into e power x square. Okay, now how can we find this? How can we evaluate this? At x is equal to 0, this value will be 1. Okay, so we can replace this with 1. Now we have this. Okay, what do we do? We split from this plus sign, we find this definite integral over minus 2x plus f of x over minus 2. Okay, we have limit x tends to 0. Here we write separately limit x tends to 0. Okay, now here we can put x is equal to 0. We can use direct substitution. So this will be f of 0 over minus 2. F of 0 is 1. So we have here minus 1 upon 2. Okay, now this is still indeterminate form, 0 upon 0 form. We can use L'Hopital rule. We differentiate numerator and denominator separately. We find f of x over minus 2 for limit x tends to 0. So value of this will be also minus 1 upon 2. We get minus 1 upon 2, minus 1 upon 2 is equal to minus 1. Okay, so this option is also correct, true. Okay, now let's check this option. Okay, now we have here limit x tends to 0 of sin x into this definite integral over x square is equal to minus 1. Let's evaluate this limit. We have we can write like this, limit x tends to 0 of sin x over x multiplied by this definite integral over x. Okay, limiting value of this is 1, so we have now limit x tends to 0 of this definite integral over x. Okay, now this is indeterminate form. We can use L'Hopital rule, using which we get limit x tends to 0 of fx over 1. This is f of 0, value of f of 0 is 1. Okay, so this option is wrong, false. Okay, so correct options are A, B and C. So here we are using mainly three concepts: L'Hopital rule of limit, Leibniz rule of definite integration and Rowley's theorem. Okay, okay, now we have one more question from definite integrals. Question is if I is equal to this definite integral, then find the value of 9i. Here integrand function is greatest integer of root 10x over x plus 1. Lower limit of integration is 0, upper limit is 10. Your square brackets represent greatest integer function. How can you find value of such integrals? Integrals involving greatest integer functions. We have done this in separate video. We have one special concept of integration of functions involving greatest integer function. What do you do first? We first check the nature of function inside brackets. Okay, suppose this is function fx. We have fx is equal to square root of 10x over x plus 1. We can write like this, square root of 10 multiplied by 1 minus 1 over x plus 1. We first check the nature of function. We start with x plus 1. In any interval this function is an increasing function, so 1 over x plus 1 will be decreasing function, minus 1 over x plus 1 will be an increasing function, so 1 minus this and hence 10 into this, and hence square root of this will be an increasing function. Okay, so function fx is an increasing function. Then what do? We find the values of fx at endpoints of intervals. Here we have values 0 and 10. Value of f of 0 is 0. Okay, and value of f of 10 will be square root of 100 over 11. Okay, 100 upon 11 is 9 point something, so its square root will be 3 point something. Okay, so fx moves from 0 to 3 point something when x moves from 0 to 10. So greatest integer of fx will be discontinuous when fx crosses three integers, 1, 2 and 3. There will be three integers in the interval 0 to 3 point something. Okay. Now we find the corresponding values of x. We will get corresponding values 1 upon 9, 2 upon 3 and 9. For fx is equal to 1, value of x will be 1 upon 9. For fx is equal to 2, value of x will be 2 over 3. And for fx is equal to 3, value of x will be 9. Okay. So what do? We split the limits at three values, 3 points, 1 over 9, 2 over 3 and 9. Okay. So I becomes, I is equal to, first we have limits 0 to 1 upon 9 when x belongs to this interval, fx belongs to open interval 0 to 1. Okay. F of 0 is 0, f of 1 upon 9 is 1. Okay. For fx is equal to 1, we are getting x is equal to 1 upon 9, means f of 1 upon 9 is 1. For these values of x, fx belongs to open interval 0 to 1, so its greatest integer will be 0. Okay, got it. Then we have interval 1 upon 9 to 2 over 3. For these values of x, fx will lie in open interval 1 to 2, its greatest integer will be 1. Okay. Next we have interval 2 upon 3 to 9. Okay. We have here 2. Okay. Then we have 9 to 10. Here we will have 3. Okay. Now we find this value. We find, you calculate yourself, you will get 182 over 9. Okay. So value of 9i will be 182. Okay.